Hey guys, it's Dr. Franklin here. I was just going to show you real quick a tip on homework problem number 2. This is in section 2.3 when we're talking about quicksort. So in this problem, you'll notice as you read this that it says show in the style of a quicksort trace how quicksort sorts the array. Easy question, but for the purposes of this exercise to ignore the initial shuffle. Now the problem is that this solution that they provide on the website actually does an initial shuffle, so it's not going to be correct. It's going to actually end up with the correctly sorted algorithm, but all the steps are going to be different. So as I was walking through this, I really had a challenging time, even myself, trying to figure out in each case where the partition ended up and breaking down the partitions and doing each one in each piece. So what I did was I cheated a little bit, and I was going to actually encourage you to do the same thing. I don't mean cheat by look at the answer, but I cheated by going back to the source code. So I pulled the source code for Quick off of the website. Quick.java is available there on the algorithms textbook website. And so in doing this, I went in and I inserted a few things. First of all, I turned off the random shuffle and the assert that it is sorted. Actually, I don't think I had to do that second thing there. But now deep inside the sort command, I added a couple of print line statements here to output what the low value was, the J value is after the partition, and the high value, so that I know what it's calling whenever it does the recursive part of the quicksort. But it also will tell me where my J is, and it just helped me to visualize a little bit better what was going on. I think once I saw it in action, it helped me to figure out exactly what was going on. So once I compiled this and then ran it by using easy question as my input, I just made a little text file, easy question. I compiled this in Dr. Java, and then I ran this from the command line so I could pass it easy question. So I don't know if you can see what I've got here, but I'm running java-algs4, the quick executable that I created, and then passing it through standard in the standard input, the easy question.txt. And so first time through, it's going to look from 0 to 11. That's the beginning to the end of the array, and then the first place that it finds is 2. Now, if you figured out problem number 1, you would see why J is number 2 after that first run of partition. So I'm doing this in Excel to draw this for me, but as I look through this thing right here, in fact, I'll go back to problem number 1. What it does, remember, is from 0 to 11 here, it's going to use the first one as the one that it's going to move, and it moves from the left over here, adjusting I until it finds one that is bigger, that is after E, and so that's going to be this S right here. So that's why I is 2, and it's also going to move from the right until it finds one that is either less than or equal to, and so it stops here at the E. Okay, and now it's going to exchange those two values. Okay, so the S and the E get exchanged, and now we're going to continue moving to the right to find anything that is greater than or equal to. Notice these are all greater than or equal to all the way to the end. So actually I'm done, and my J value turns out to be this 2 right here. I don't know why I've got 3. Yeah, I think on my answer key I've just got this wrong. This should be 2, 2, and 2, because that's where it ends up. And now this is where the partition is. That's now the element that's in its right place. Everything to the left of it is before it. Everything to the right of it is after it. So that's why on the first step we end up right here. Okay. So now what we do is we look at these two. Right, and again, peeking in what happens, notice that that's the left-hand side of the array. We're now going to run the sort on that. Those are in opposite order, so they end up switching places. Your J ends up being the second, or in this case, the one indexed value of that array. Okay. And as you run through this, you'll see that every time that I get to a place where the low and the high is equal, or low is bigger than the high, that is this condition that breaks out of the loop right here that tells us that we're done with sorting that piece and can move on to the next piece. Okay, I don't know if that helped at all, but that's what I did to approach this problem, was to go through and throw in some standard outputs inside of the code to see what the array looked like each place. That's what I recommend that you do. Okay, um, and if you keep going, you'll see actually I've got the whole answer I just had on the screen. You could probably pause it and take a look at it, but that's where the array progresses as it goes through. It doesn't have the coloring, so I think that would be helpful if you did that yourself, and keep looking at the lines as the array changes throughout the quick sort algorithm. All right, that's it.